inner class of static block, and let's say here I'm taking one method because we need to access the method now. Public static void m1, and here let's say m1 static method. M1 static method. M1 static method. Then you can see outer class is containing a static block, inner class is containing static block, and inner class is containing static method. So object is not required. Object is not required. Even in the last Sunday also I told you that type of example when I was telling you how to create the object. So here object is required, not required, because all are the static combination. So foo outer is what? My outer class, and inner is my inner class. So let's see. Foo outer. Foo outer dot inner dot m1. So look, what will happen? What will happen? Please look, all of you. What will happen to this program? So when you try to look, when you try to write when you try to write foo outer, first of all, what? First of all, JVM will see where is my foo outer. Here is my foo outer. Okay. Then you are not accessing any member of what? You are not accessing any member of foo outer. You are not accessing any member of foo outer. Okay, you know how to load a class. How to load a class. How we are loading a class. There is a one way to load a class that what we can access the member of like inner class. I'm writing M1 method. M1 is a static method in inner class. So how a class will be loaded? If you try to access the static member, or if you create the object, then only your static block, your static block will be executed. You know very well how many ways we can create the, how many ways we can load the dot class file. How many ways we can load the dot class file? Please look here. Please look. Outer class static block. Why outer class static block executed? Simply you are creating the object for outer class. So this is one way to load your static block. This is one way to load your static block because you have created the object for what? Outer class. You have created the object for outer class. So outer class is loaded, outer class static block is loaded, outer class static block executed. In that situation, are you loading inner class? No. Second one is what? Second one is what? How to load a class. If you are accessing the static data member, that is a static variable or static method. All these things I told you in JVM architecture in more detail. So now you can see what you are doing. You are what? You are accessing the M1 method, but M1 method is present in inner class. M1 method is present in inner class. And you are writing foo outer dot inner dot M1. Foo outer dot inner dot M1. So foo outer dot inner dot M1. So you are trying to access this M1 method. This M1 method is a static. So first of all, what will happen? Your inner class static block will be executed, and then only your outer class static block will be executed, and then you will get this method, M1 method. Please look the output sequence. Inner class static block. Okay, here you are not taking what? You are not taking what? Any variable. Wait. Actually, here I am not taking any variable now. Wait. So here, look at here what happens. Your inner class static block executed, M1 static method executed. How? Why it is not executed? Because it is not accessing. You are not accessing. You are not creating the object. You are not accessing. Do one thing. Wait a moment. Static int x is equal to 15. You are not creating the object for outer class, or you are not accessing any static member from outer class. Now you do one thing. M1 static method, and you print this x. Now what will happen when you try to print this x? When you try to print this x is located in the foo outer class. So JVM has to load this foo outer class also. Please look this time the out. Inner class static block first, outer class static block, M1 static method, and you are getting the output 15. Tell me, you got the idea, all of you? Please write in the chat window, you got the idea or not? You got how class is loaded? All of you, right? This is total your JVM architecture concept. Why the outer class not loaded? Because outer class, neither you are creating the object nor you are accessing the data member of outer class. That's why outer class was not loaded. Good. So that program I will show you. Miss later I will give you. Go. Next, sir, I understood. So during the class loading phase and inner class, okay. This is example one. Okay, example one. Now do one thing. Remove this. Remove this non-static block and remove this one also. Remove this one also. This is what inner class non-static block. And this is a static method. That's why it is showing error. Because from a static method, you cannot access non-static variable. Now, all are what? All are what? All are what? All are what? Non-static combination. Non-static combination, you know, object is required. Now, object you cannot directly create for inner class. Last Sunday I told you. Because inner class is the part of outer class. So first you need to create the object for outer class, then only you can create the object for inner class. So let's see how to create the object. So here what I'm writing, let's say, I can create the object in a single line. I will tell you today also. So what is the class name? The class name is foo outer. Foo outer dot inner f is equal to new foo outer dot new inner semicolon. And then what is your method name? Your method name is M1. It is a what? First you have created outer class object and then you have created inner class object. You can also do in the two line. You can also do in the two different lines, all of you. Now it is a completely what? Non-static combination. Look, outer class non-static block and what? Inner class non-static block. Why? Because first you are creating the object for outer class and then you are creating the object for inner class. Why, sir? Because to create the object for inner class, first of all, outer class object is required. First of all, outer class object is required. Then only you can create the inner class object. Tell me, all these 2 points clear? Can I proceed now further? Come on, come on, come on, come on, come on, quick, quick, quick. Good. So look now, what is the next point? Sir, for non-static nested inner class, for non-static nested inner class, outer class object is required. We cannot create the object directly. We cannot create the inner class object directly. Outer class object is required. Why outer class object is required? Because your inner class is representing the non-static member of outer class. That's why. The last point, it is also known as regular or member class. Now let me go to the programs. All of you, look, I'm going to show you the programs. So let's say here, C drive. Java. Inner classes, first program. Look, all of you. And some theoretical part is also there. So that 2 programs I will give you, wait. Or first program you can take, no problem. Look, so here Bash 37 notes. First program, before taking this program, you can take this program directly. Okay, and this program now, you do one thing. Don't create the object in a single line. Create the object in what? 2 different lines. So foo outer FO is equal to new foo outer. New foo outer. And now foo outer, foo outer. Look at how you are representing the inner class. Inner class you cannot directly represent. Again, you need to take the reference of what? Foo outer. Foo outer inner in is equal to, you have object, your object is already there in FO. So you can take FO dot new inner. Right. First you have created the outer class object. This is what? Outer class object. This is outer class object. And this is what? Inner class object. And now you are calling what? In dot M1. Sorry. Run this. Outer class non-static block, inner class non-static block, M1 method, and you are printing the value 50. Okay. Take this. Go to your notes. How to create object for inner class. And instance block execution flow. Instance block execution flow. Okay. So note here, first of all, outer class non-static block will be executed. Non-static block will be executed. And then only inner class non-static block will be executed. Be executed. Because first we are creating the object for outer class, and it is required. It is required because inner class is a non-static member. Non-static member of outer class. Great. This is the first program. Miss what? One simple program I have given to you. Now let's see. Quickly, I'm going to another program. What is another program? Concentrate here. So let's say program number first. Look quickly. Concept you got. Now I'm going to the program. So class outer private int A is equal to 15. Class outer private int A is equal to 15. You can see you have an outer class. In the outer class, you have a private data, and then you have an inner class. Outer class, you have a private data, and you have an inner class. Okay, inner class. So inner class, you can declare private, default, protected, public, abstract, final. That I will show you another program. And here what you are taking, here you are taking public void display value. And from this public void display value, you want to try to access the private data of outer class. Getter is required. Required. Why? Because it provides strong encapsulation. So without getter, inner class can directly access the private data of outer class. My heart can easily access the blood of my body. Department can directly access the facilities of university. Permission is not required. Getter is not required. Getter is not required. Engine can directly access the car properties. So if you start the car, actually your engine got started. So permission is required. No, because they are the integral part of the object. Both are the integral part, the integral object. Car is containing engine object, person is containing heart object. Okay. So you can directly access the private data of what? Outer class. That is the beauty. Okay. Now here, look here how you are creating the outer and inner class. So outer out is equal to new outer and outer dot inner. Look, even you are creating the inner class object, you need to take the reference of outer. You cannot write directly inner. Compiler will not understand because inner is inside outer class. So outer dot inner in is equal to out. Out is holding the reference of outer class object, and with that out new inner, and then in dot display value. In dot display value means what? Value of A is what? A. Compile and run. Value of A is what? 15. Take this program. Let me check, is there any theoretical part is there? Look at an inner class can directly access the private data of outer class. An inner class can directly access the private data of outer class. Program number 2. Look, guys, what is program number 2, all of you? Look, so class my outer, private index is equal to 7. Okay, class my outer, private index is equal to 7, public void make inner. In outer class, you are creating one method. In the outer class, you are creating one method. That method name is what? Make inner. And wait, we will go to this method. Here you are creating one class my inner. That means your outer class is containing one class and one method. And in this my inner class, private int y is equal to 15. Private int y is equal to 15. Public void C outer. That means I want to access the outer data. And please look here. Public void C outer. Outer x is what? X. Outer x is x means what? This x value you are trying to access. So obviously from the inner class, we can access the private data of what? Outer class. But here you can see in the make inner method, which is a method of outer class, you are creating the object for inner class. My inner in is equal to new my inner. You are creating the object. And then system.out.println inner y is, you are writing what? In.y. In.y means what? This y you are trying to access. Whose value is what? 15. This y you are trying to access, whose value is what? 15. And then you are writing what? In.c outer. From here, you are calling this C outer. C outer means what? This method. Because your inner class object is already created. Okay, your inner class object is already created. You are getting the what value, and then you are calling this C outer method. Okay, fine. Then my outer m is equal to new my outer and m dot make inner. M dot make inner means what? First of all, you are creating the object for outer class, and you are calling the method make inner. Where is make inner method? Here is make inner method. And in this make inner method, you are creating the object for inner class. And after creating the inner class or object of inner class, you are trying to access this y variable. Okay. And then you are calling what? C outer. And from this C outer, you are trying to access the private data of outer class. Compile. No problem. Perfectly it will compile and it will execute. Inner y is 15, outer x is 7. So from here, inner y is 15. Where is 15? Here is 15. And from here, outer x is what? Outer x is 7. Good. Look, variables shadow in nested classes. Interesting concept. Look, an answer. What I will ask. Variable shadow in nested class. What is variable shadow? Wait. New package com.ravi.variable shadow. Click on finish. Right click, new class, learn. I will ask the answer. Give the answer. Variable shadow. Main method, click on finish. Here, let's say we have a class outer. Private int x is equal to 100. All of you. Then class, here you can take public class also, no problem. Public, private, your choice. Public class inner. Public class inner. Okay, public class inner, you can see. And in this inner class also, we have a private int x is equal to 200. That means outer class is containing x value 100, inner class containing x value 200. Understood? Outer class containing x value 100, inner class containing x value 200. And now here I have a method. Public void access. Public void access. Sys out. I'm trying to print x. I'm trying to print x. And here in a single line, I can create the object how? Outer dot inner, outer dot inner, outer dot inner in is equal to new outer dot new inner. Okay. Outer dot inner in is equal to new outer dot new inner. And then from inner class object in dot access. In dot access. Okay. Can you please tell me what it will print, 100 or 200? Quickly write in the chat window, all of you. Quickly write in the chat window what it will print. 100, 200, 200. Very good. Let me run this program. It is printing 200. That's great. So you can write what? Inner class X variable. You can write like this. Inner class X variable is what it is printing 200. Now, can you tell me how to print outer class X variable? If I want to print outer class X variable, think. Guys who are writing super, use at least sense that it is not an inheritance concept. I'm getting so many options. Super. Why super, sir? It is an inheritance concept. Inner class is a child class of outer class. Huh? Someone is asking this. This means what? Current object. Whose current object is there? Your inner class current object is there. No effect in output. It will print 200 only. Current object. What is current object? Current object is your inner class object. Now here what object is working? Inner class object is working. And super, how you can use super? Huh? Super means, are you understanding? It will go to object class. Outer is the super class for inner class. Okay, then what to do? Then what to do? Actually, when I was teaching you this keyword, of course you might forget, but when starting phase, when I was teaching you this keyword, then I told you that you can also use class name with this keyword. Then I told you later I will give you the idea where it is useful. Look, so what is the solution? Outer class X variable is outer class X variable is. Once again, you look at this dot X, you cannot write. This means it will always represent the current object. Current object means what? Inner class object. Inner class object means the value 200. How to access this outer class? So here you need to write what? Here you need to write what? Outer dot this. That means outer class current object X variable. Outer class current object X variable. Now look what output you are getting. Now you are getting the X variable is what? 100. That is the solution. That is the solution. In this part, this point I told you in the this keyword. That's what in the this keyword you can also write class name. When I was teaching you the static variable means how many ways we can miss what? What are the what? Sir, this one. Wait, which one? Just hold on. When I was teaching you this one, this concept, local search algorithm. Look, this one. A static int A is equal to 100, int B is equal to 200. So I told you, look here. Here automatically compiler, because A is a static field. A is a static field, so compiler will automatically add what? Test.A. B is a non-static field. B is a non-static field. B is a non-static field. So compiler will add what? Compiler will add this keyword. Compiler will add what? This keyword. So that time I told you that in this keyword, you can also apply class name. You can also apply class name. Okay. How that class name will work today you understood. Once again, you look at what is happening here. A very simple program where the class is containing one static field and non-static field. Okay, then how? Method area. In the method area, what? A value. A is a what? A is a class level variable. So 100% default value will be generated. And then you are initializing with 100. And now what will happen? Here compiler will automatically look, compile. You have written A, but what compiler will do here? Compiler will write test.A like this. Understood all of you? That point I told you. So today you understood what that point in more clear way, because here variable scope is there. So this dot x means current object. Outer this dot x means what? Outer class variable. So what is variable shadow? Look, variable shadow in nested classes. Learn. Now the nested variable shadow I have already discussed, so I'm not talking. Look, if outer class and inner class variable names are same, if outer class and inner class variable names are same, then inner class variable will be accessed with inner class object, variable shadow. Okay, because in the same scope, if we want to access outer class variable from the inner class, then we need class name, this keyword, variable name. Class name is what? Outer class name. Outer class name, this keyword, variable name. This is what your variable shadow concept. Variable shadow concept. Because your inner class variable is going to hide outer class variable. Guys, you got this point, everyone? Please write in the chat window. You got this point? Variable shadow? Okay. Move. Sir, look, simple, sir. Very simple, this one. Look at class my outer private index is equal to 15. Class my inner public void C outer. From C outer, you can access the private data of what? Outer class. Of course. And here you can see what I have done. I have created the object my outer, my inner. M is equal to new my outer, new my inner, and then M dot C outer. Nothing is there in this program. Outer X is what? 15. You are creating the object for in a single line. You are calling C outer method, and the C outer method, what you are doing, you are trying to access the private data of what? Outer class. Good. Now you can see here class my outer. The static index is equal to 7. It is a static variable. It is a static variable. And you can see here Couter is a static method. Couter is a static method. So what will happen when you load, when you write this my outer, my inner dot couter, due to this couter, because couter is a static method, you can directly call with the help of class name. Couter is a static method, you can directly call with the help of class name. So what will happen due to this couter, this class will be loaded. Due to this couter, this class will be loaded. And now this x is a static variable which is available in the outer class. That means this outer class will also be loaded. So first of all, First of all, my inner class will be loaded and then your outer class will be loaded because this the static variable is available in the outer class. But here look, all the static combination, you have a static variable, you have a static method, and from here you are calling this a static variable. So it is about all the static combinations. So object is not required, you can directly call. Okay. When I will teach you the static nested inner class, I will give you more idea about that. Okay, when I will teach you static, our next concept, a static nested inner class. Right now we are learning non-static nested inner class. There I will give you the complete idea. This is just, I want to show you one thing, what? That if you have a static combination, object is not required. Object is not required because you have a static method. So automatically this my inner class will be loaded. My inner class will be loaded. Okay, and now you can access this static method without object creation. And from that static method, when you try to access this x variable is available in outer class. So outer class will also be loaded. Next. Look, now inner class real programs are going to start. Please look. Class car, private string make, private string model, private engine. You can see three variables are there. Make, model, engine. Okay. Learn carefully. Car and engine concept. Beautiful concept. You will get the idea of what exactly your inner class concept in real time. So car is having three what properties: make, model, and engine. You can see engine is there. Now this engine, look, all of you, this engine if you use in multiple cars, the engine if you use in multiple cars, then you can take this engine class outside. Beautiful line it is. If you know that this engine class, this engine I can use in multiple places. Today I will use in this, let's say I have total 4 Swift Desire car. Today I will use this engine my first car. Tomorrow I will use in another car. Next day I will use in another car. Next day I will use in another cars. And then next day I will use in the first car once again. If you are if you have this kind of approach, then you can make this engine as a what? In this, you can make this engine as a outer class. Means what? You can take another class engine and you can use this engine class in the car class. But if you are telling no, my engine and my car both are tightly coupled. Okay. Both can directly access their data. So what you can do, you can declare one inner class. Look here. Inner class, private class engine. Inner class, private class engine. Now look carefully. So three properties are there. But please look, please notice that this car class constructor is not taking these three properties. This car class constructor is not taking these three properties. Then what it is taking? It is taking make, first property. It is taking model, second property. But it is not taking engine. It is taking horsepower. Because if you want to create engine, horsepower is required. Now here, this dot make is equal to make, this dot model is equal to model, this dot engine is equal to new engine. At the time of creating engine, you are passing horsepower. That means engine class constructor must contain what? Horsepower, which is of integer type. So let's say, where is engine class? Here is engine class. Here is private class engine. Private int horsepower, only one property in the engine class. When you create the engine object, this horsepower is going to initialize, and then your property is going to initialize. Your horsepower is a parameter variable through which engine class property will initialize. Okay. So please look at once again that in the Car class constructor. You are taking make, you are taking model, and you are taking what? Horsepower. Make, model, and horsepower. Okay, great. And with that, your engine class object is created. With that, your engine class object is created. Now you can see in the engine class, you have a start method. In the engine, look, guys, whenever you are running, look, like I have a laptop or I have a car. Whenever I will start the car, let's say started with the key, I started the car. So car started, but internally what started? Internally engine started. Whenever you open your laptop and you press the power key, you press the power key in your laptop, then what happened? Your laptop power key on. But internally what happens? Your motherboard booting process started. Nah, please try to understand. Two start things are there. You are starting laptop from externally, but internally motherboard booting process started. Give me 1 minute. Okay, understood. So like that. Similarly, you think you started your car. Okay, I started my car. Then internally what started? Engine started. So you have a start method. This start method is engine start method. And it is printing engine started horsepower. Means whatever the horsepower you will give, engine started horsepower 1000, engine started horsepower 1200, like that. Then you have a stop facility. These are engine class. Then engine stop. Like this message will print. Okay. This is what your what class is completed. What class is completed? Your engine class is completed. Your engine class is completed. What engine class is containing? Three things. One constructor through which we can initialize the horsepower of engine, and two methods of start and stop. Two methods start and stop. And please look here. Here inside the car class, guys, because your engine is a inner class. Your engine is the inner class. Inside the car class, car class, public void start car. Okay, public void start car. Wait. Just wait a minute. One student is there, Surender. I think he has joined 10 times and he has left 10 times. Why he's doing like that? Remove that from meeting. If you're busy in some another place, busy, why you're disturbing the whole class? Look, public void start car. Public void start car. It is a start car method. That means you are starting the car. So it is a start, means what? Car start method. You are starting the car. When you start the car, what will happen? A starting make means what you have given in the car. Make, model. What is the car model? What is make model? This is make model. Your car properties. Your car properties, make model, your car properties. And you are starting the engine car. Your car class is ended where? Your car class is going to end. Your car class is going to end at line number 46. Your car class is going to end at line number 46. And then you have taken what? Start car. Public void start car. System.out.println starting make model. Starting make model. Like that, it will show starting make model. I'm starting this make and model. And then internally, when you starting your car, internally what started? Your engine get started now. This dot engine dot start. This dot engine dot start. This means what? Car class object. And car class object contains engine class properties. Car class object contain engine class properties. Engine is available in the car. Where? Wait, here. Here, engine. Engine. So when you start this car, so what will happen? Your car class, with the help of car class, your engine is going to start internally. That is the beauty of inner class. This is the beauty of inner class. Whenever you stop the car, what will happen? You are stopping the car, but internally what your engine gets stopped. So in the outer world, is what any end user, what end user can see? End user can see only the simple things. What? My car is there. My car is equal to new car, Swift, Desire, and 1200. Swift, Desire and 1200. So what will happen? Swift, Desire 1200. Swift will assign to this make. Okay, this make Swift model and then horsepower. So Swift, Desire, model is the Desire, make is the Swift, Desire is the model, and 1200 is the what horsepower. And then what you are doing, my car dot start car. Whenever you are starting the car, internally what will happen? Your engine get started. My car dot stop car. Look, you can't see any internal details. Your end user can't see. Your end user understands only one thing. I am starting the car. But whenever car is started, what happens? Internally, it will start the engine. Internally, it will start the engine. When engine will start it. When engine will start, what it will print? It will print engine started with 1200 horsepower. Guys, tell me you understood this program? All of you, simple program. Please write in the chat window. You got the idea? You understood this program? So that is the power of inner class. That is the power of inner class. Your end user can see, like I can see my laptop only. I can start my laptop, but internally motherboard started. I don't know the internal details. I don't know the inner details. I can see only the UI part, and I am going to interact with the UI part. When you are interacting with the UI part, internally what happens? Internally what happens? Internally your object is what? In the inner class object is created, and all those things are going to happen internally. Okay. String car make is not suitable. Let's say I'm taking what name? Change this name. It's confusing. Make name. This dot name is equal to name. Compile. Run. Look, starting Swift Desire. Engine started with horsepower 1200. Stopping Swift Desire. Engine stop. So this is a very beautiful program to understand the inner class concept. Next. Look, this is what same type of program with the what laptop and motherboard. You have a laptop, you have a class laptop. The laptop class is containing what? Look, brand, laptop model, and it is also containing what? Motherboard. Again, same question. Again, same question. Can I use this motherboard in multiple laptops? Let's say Monday in this laptop, Tuesday in another laptop, Wednesday in another laptop. If yes, then make this motherboard as another class. Take another class motherboard and use the motherboard class as a property in the laptop class. But if this motherboard is the integral part of the laptop, you can use only in a particular laptop, then this motherboard must be your what? Inner class. This motherboard must be your inner class. So what this motherboard is containing? This motherboard is containing two properties: private string model, private string chipset. Private string model, private string what? Chipset. And you can see public motherboard. Click motherboard here. By using this parameterized constructor, you are initializing the motherboard properties. What are the motherboard properties? Model and chipset. And in the motherboard, what methods we have? Only one method we have. Only one method. Booting process. Only one method we have. Booting process. So booting process means what? Booting process means what? Look, system.out.println. Booting brand. Brand is my laptop brand model. My laptop model with chipset. With chipset. So whatever the chipset you will pass here, that chipset. So that is what boot. Now what you are doing, you go, this is motherboard. Motherboard is having what? Two properties, one parameterized constructor to initialize the properties and one booting process. One booting process means what? When you start the motherboard, when you start the laptop will start internally what? Booting process, motherboard will start. Okay. Then you go to the laptop class. In the laptop class, you have a brand model and what? Motherboard. brand, model, and motherboard. You can see parameterized constructor is there. Brand, model, brand, model. And please look here, you are not taking motherboard, because if you take motherboard directly, you have to take the object from the another class. Na? Please look at this one. You are not taking motherboard at a time of creating the object of laptop. Otherwise, it's a loosely couple. Otherwise, your motherboard is created separately and you are fitting inside the laptop. So when your laptop object is being created, you are taking brand, you are taking model, and you are taking motherboard model. Now what you are doing, this dot brand is equal to brand, this dot model is equal to model, this dot motherboard. When you are developing the motherboard, at a time of developing the motherboard, you are passing motherboard model and you are passing chipset. That means at the time of development of laptop, you are what? You are giving the brand, you are giving the model, and you are giving the what? Motherboard model as well as chipset. And in the laptop, what? You have one method, public void switch on. You are going to switch on the laptop. Turning on brand model, let's say turning on Dell model is what? 2025. And this dot, this means here what current object? Motherboard, sorry, laptop current object. So on laptop current object, you are calling motherboard. What is motherboard? Motherboard is your reference variable, sir. Motherboard is your reference variable. And this dot motherboard dot what? Boot. Then what will happen? Motherboard class boot method will be invoked. And what it will print? Booting brand model with chipset. This one. Look at here. In the outside, outsider can see what? Laptop is equal to new laptop. HP. HP is the what? Model. HP is model. What I have taken? Model. No? Let me check. Sorry, HP is a brand. And model and what? Motherboard model. And chipset. Four things. Brand, model, motherboard model. So brand HP, model NV, motherboard IRICL, and chipset is what? Intel. And then laptop dot switch on. Compile. Run. Look, turning on HP NV, booting HP IRS with what? Intel chipset. Let me check, is there any theoretical part is there? No. One more, look. One more, all of you, please concentrate. One more concept is there. Person. Person is having name, age, and heart. And heart. Then public person, name and age. I'm giving the name and age of the person. And this dot name is equal to name, this dot age is equal to age, this dot heart is equal to new heart. That means heart class constructor does not contain anything, does not take anything. It is a no argument constructor in the heart class. So I'm not taking anything here. I'm taking only name and age. Your choice based on your requirement. Go to the heart class first. Look at heart class. Heart class you are declaring private. Anything you can declare, no problem. Private class heart. Look, whether it is private or whether it is a what public or anything, what with the permission of outer class only you can access heart class, inner class, because inner class is a part of outer class. When that bash 38, your linked list class is containing what? Node class, and linked list class is what? Outer class. So private class heart, private int bits per minute. So heart is having bits, its own functionality. What is the functionality? Bits per minute. Heart is having its own functionality, bits per minute. And you can see here, you have no argument constructor. In this no argument constructor, you are directly writing this dot bits per minute is 72. That means what is your heart bits per minute? 72. Heart bits per minute is what? 72. This is no argument constructor. And please look at here. You have a what? Public void set bits per minute. You can set the bits, means what? You can set the what? Heart bits minute. Is what? If you want to modify from 72 to let's say 80, someone is having 80, you can have a option, you can what? Modify also. And by using this get bits per minute, you can get the heartbeats. What is the rate of heartbeats per minute? You can modify also. If let's say one person, that person heartbeat is 75 or 80, then you can what? Modify also. So these are what? These are the properties of heart class. Here you can see public person, a string int name, age, and name, and here we are at the time of creating person object. I will create heart object also. And this person is calling what? This person is having one method describe where I will print name, I will print age, and then heart bits per minute. This dot heart, because heart is what? Heart is my property in the person class. And from that heart, I can call this getter method. What is the getter method? Get bits per minute. And if you want, you can modify also. Okay. Person is equal to new person, Virat. Virat is the name, age is 30. Person dot describe. Compile. Run. Name Virat, age 30, hearts beats per minute 72. Good. Look, one more that type of program, all of you. What is that? Look, class university. You know, university department relationship. Class university private string name. Class university private string name. This is what? This is your parameterized constructor through which you are initializing the university name. That means you are what? Your university name is what? Your university name is initialized at the time of creating the university object. And then you can see here public void display university name. By using this method display university name, you can display the name of the university. This method is only to display the university name. And here you have, look, you can see here you have a department which is running under the university. In the department, we have what? Name, name of the department, and head of the department. Who is the head of the department? Name of the department, head of the department. I'm taking one parameterized constructor. In this parameterized constructor, you can see name and head of department. Name and head of department. So this dot name is equal to name, this dot head of department is equal to head of department. Method to display department details. Method to display department details, public void display department details. Public void display department details. Now from display department details, I can directly call display university name. Why? Because it is a strong relation, encapsulation. So when I call, whenever you are saying to display department, that department, can you tell me what is your name? Display department. So display department name is different and university name is different. So your department can access the university name. What is display university name? Please look. Display university name is this one, which will display the name of the university. Great. After that, department name is what? Name. Department name is name. And head of the department is what? Head of the department. So name and head of the department, how they are initializing? They are initializing with the help of this constructor. Damned easy concept. So here what you are saying what? University is equal to new university, JNTU, Jawaharlal Nehru Technical University, available in our Hyderabad. And university department, look, department is the inner class. So university dot department CS is equal to university. University is representing outer class object. New department, what is the name? Computer science and Dr. John. Computer science and Dr. John, look, computer science is the name of the department. Who is the head of the department? Dr. John is the head of the department. Okay. Similarly, university dot department E, university dot new department electrical engineering, Dr. Scott. So CS branch head of department is Dr. John. E branch electrical engineering branch head of department is Dr. Scott. Then CS dot display department details and E dot display department details. Look, both will print university name. University name is JNTU, department name computer science, head of department Dr. John. University name JNTU, department name electrical engineering, head of department Dr. Scott. Batch 39, do you have information that you have a class at 9 a.m. right in the chat window? Or class is cancelled? Class is there? No. So two more programs are there, and then what? This topic will be completed. Then we have what? A static nested inner class topic will be in the from next Sunday. Okay, two more class, two more program, simple programs are there. Look quickly. Let's say within 2 or 3 minutes we are going to complete. Class outer class private index is equal to 200. Class outer class private index is equal to 200. Class inner class. Class inner class. Look, outer class you have a private variable. And inner class you have a display method. You have a display method. Just what I want to say, that you have a display method in the inner class, and you can see this is the inner class, what inner class body. You can see one more display method is what, which is available in outer class. That means inner class is containing one display method. Inner class is containing one display method. Outer class is also containing one display method. Inner class and outer class. So inner class is having display method, which is printing what inner class display method. And here in the inner class, we have another method get value, which is calling display method directly. We have a method called get value, get the value, which is calling display method and can access outer private var x. That means this x variable you want to print. Of course, it is possible. So from inner class, you can directly access the private data of outer class. And here what your outer class is having also display method. Public class test9, comment this line first. Outer class, this is your outer class, line number 1, and then inner class. This is your inner class. Okay, outer class, inner class in obj. Outer class, inner class in obj is equal to new outer class, new inner class. Okay, that means you are creating the object for inner class. So in obj is holding what object? Inner class object. For inner class object, you need to create outer class object. Why? Because inner class is a non-static member of outer class. Good. Then from here in obj dot get value, it will call get value method. Now it will call which display method? Inner class display method or outer class display method? Right in the chat window. Please say. So guys who are saying inner class display method, all are saying all inner class. Okay, it will call inner class display method. Why? Obviously here this get value method is called with the inner class object. No? The get value method is called with the help of inner class object. So inner class display method will be invoked because here current object is inner class object, not outer class object. Please look, you will get inner class display method. Inner class display method and then can access outer private var x is equal to 200. Sir, how to call this outer class display method? Outer class display method. If you want to call outer class display method, outer class object is required. So new outer class display. Take one SOP statement here. System dot out dot println compile run. Look, outer class display method. And the last program of the day, then we will end this session. And this topic will be completed. Not this one, 11th one. Look, not this one, 10th one. This one, guys. Last program was 9th one. This program, last program, test 9, now test 10. Last program. Look, what is test 10? Very simple. Sir, inner class can we declare private, default, protected, public, abstract, and final? Yes, look. So here I have taken public, only main method is not there. Compile. Take private, save, compile. Take what? Abstract, save, compile. Take final, save, compile. Take protected, save, compile. Even you can take a static. Even you can take a static, but if you take a static, it will belongs to second category now. Now it is a what? No, it is not a non-static nested inner class. It is a static nested inner class. So even you can take a static, no problem. But it will come to second category. It will come to second category. So what I want to say you, all these excess modifiers are applicable on your nested inner class. Okay, on your nested inner class. So this is what we have completed our first program is what first our nested inner class. Now next Sunday the timing will be not 7:30. Okay, maybe this Sunday we have a class now. Class 39 is having class. So next Sunday we will learn a static nested inner class. Non-static nested inner class completed. Next Sunday I will complete inner class concept. Next Sunday we will complete inner class concept, and with that batch 38 a Sunday class will be completed. 2 more Sundays will come for what batch 39 and 40 to learn the object class methods. Okay, object class and input output, and then your Sunday concept will be also completed. So that's all for today, guys. Thank you for joining.